While the number 13 is typically considered unlucky, those hoping for big changes in Python might regard this latest release as a miracle. In fact, without sounding too superfluous, I think this could well be the most important release since Python 3.0. Okay, I know I said that last time, but it's not my fault the Python Software Foundation keep outdoing themselves. There is an awful lot to go over here, so let's cut the fluff and get on with it, shall we? I think it's only right that we begin with the biggest news of the year. PEP 703 finally brings around a potential end to the GIL after many unsuccessful attempts in years gone by. For those unfamiliar with the GIL, it stands for the Global Interpreter Lock, and to put it simply, puts a lock on the entire global state instead of using fine-grained locks. While this does dramatically improve single-threaded performance by removing overheads of lock management, it does come at the cost of significantly worse multi-threaded performance, as only one core can access the global state at any one time. Back when the GIL was introduced, this was a trade-off well and truly worth making, and in the eyes of Larry Hastings, contributed heavily to Python's success.
I would say that the design decision of the GIL is one of the things that made Python as popular as it is today. So I don't agree with people who say the GIL is terrible, it should never have been added. No, absolutely not. The GIL, part of the reason that Python is successful is because it had the GIL.
However, technology has since moved on, and the GIL is now proving quite the barrier to many. There have been many attempts to remove the GIL, which have all suffered from the same problem. They annihilated single-threaded performance. A solution that didn't suffer as much from this problem was finally devised as long ago as Python 3.9, but more recent innovations such as immortal objects made the implementation viable. Something massive like this requires some massive changes to the core of Python, including a new reference counting system, the adoption of Microsoft's memalloc memory allocator over the current pymalloc one, as well as changes to the garbage collection system. On top of all that, huge swathes of Python's C API needed to be made thread safe. I guess they didn't really have to think about that before. Of course, this isn't a magic wand to fix all of our problems. Yet. Single core performance does still suffer somewhat, some parts of the C API still need to be made thread safe, and adoption within C libraries is likely to be slow. As such, the GIL will still be enabled by default, though you can switch it off by building Python with a disabled GIL flag. If you don't fancy building Python from source, both Dead Snakes and Anaconda have promised to release free threaded versions to their respective repositories alongside their GILD counterparts. It's worth keeping in mind that this functionality is still experimental, and if it all gets too much, it could still be scrapped. Fingers crossed that doesn't happen, eh? Oh, and if you want to know more about all this, I made a whole video talking about it in more detail, which you can watch after this. If that wasn't enough for you, CPython now comes with a JIT compiler. For those not in the know, JIT stands for just in time, which alludes to the fact that code is compiled just before it's due to run for the first time. It's often only applied to sections of code that would benefit from JIT compilation the most, such as simple operations that are likely to be run millions of times. What Python is getting is a copy and patch JIT, first proposed by Zhu and Kolstad in their 2021 paper, which generates machine code templates for various bytecode instructions at compile time, and patches these templates in place of those instructions at runtime. This allows Python to run machine code directly, providing up to 9% speed increases at the cost of additional memory usage, though this will be improved and optimized as it's developed further. This implementation of the JIT provides a few interesting upsides. There's no need to ship and maintain a custom JIT, as Clang can be used instead. It provides a great excuse to refactor complex instructions into chains of simpler and much more maintainable instructions, and we might actually see code ported from C to Python in order to increase speed. How's that for wackadoodle? As it's all still experimental, the JIT is locked behind yet another compilation flag, enable experimental JIT this time, and annoyingly can't be combined with the disabled GIL flag. Hopefully that will change in the future, but for now, if you are hoping to try the ultimate Python build with both features, you're out of luck. If you want to track the progress of the JIT, take a look at PR 115802. You're welcome. Another feature I've made a proper video for already, Python has a new REPL. Based on the PyREPL and written in Python instead of C, it aims to be more versatile and maintainable than the last one. Multi-line editing is now present, and typing exit or help without calling them now do what they previously told you to do. Oh, and there's a new clear command as well. Alongside the new colored prompts, these are all very welcome changes. But if you're not a fan, you can turn it off by using the Python basic REPL environment variable. Speaking of color prompts, error messages are now colored. The pink and red, or synthwave as it's very unofficially called, is not only designed to liven up error messages a little, but was chosen specifically as they have the same contrast on both light and dark backgrounds. If you don't like them, you can turn them off by setting the Python colors environment variable to 0. The error system can now also detect when a local file is shadowing a module. That is, when you've called a file, for example random.py, then try to import the random module from the standard library. On top of that, it can also now give you a helping hand when you've misspelt a keyword argument. Unfortunately, one thing that isn't coming to Python 3.13 is the deferred evaluation of type annotations, which is now scheduled for 3.14 instead. I hope you're ready to hear all about that next year. Some other ideas that didn't make it to 3.13 are a converter argument to data class fields, and module level setAttr and delAttr methods, which are both rejected, and the interpreter standard lib module for spawning subinterpreters, which has been deferred. If you're looking forward to the latter, there are potential plans to release it on the Python package index, but nothing concrete as yet. On the topic of things not coming to 3.13, there is a plethora of modules marked as dead batteries when Python 3.11 was released that are no longer present. These are all old modules that haven't been updated in years, have been superseded, don't have maintainers anymore, or in Shadow Password's case, pose security concerns. Some additional modules such as OptPass were on the chopping block, but were saved by the skin of their teeth by objections from the community. Isn't it nice when people actually listen? Good news for mobile developers now, both iOS and Android are now officially supported platforms. They come in at tier 3 for the time being, which means they have a build bot and at least one core developer supporting them, though may lack non-source builds and failures don't block releases. This is how every platform starts life in the Python ecosystem though, and I imagine they'll be promoted to tier 2 in, at most, a few releases time. While we're talking about releases, there's been a change to the release schedule that's worth pointing out. Starting with Python 3.9, new minor versions were released every year, each with a 5-year support window, 1.5 years of full support, and 3.5 of security fixes. However, from Python 3.13, releases will have 2 years of full support instead. That will of course be followed by 3 years of security fixes, bringing the total to the same 5 years as before. And finally, I want to run over some other cool things that have been added. You can now encode and decode Z85 data, which admittedly was not a standard I'd heard of before this, but it sounds great. Interestingly, this is done in the base 64 module, but hey, everything needs a home. The copy module now has a replace function and corresponding protocol to allow for creating modified copies of objects in a much nicer way. The doctest module for writing tests in documentation now has a coloured output. Wait, hang on. How long has that been around without me knowing about it? The itertools.batched function introduced in Python 3.12 now has a strict parameter which ensures all batches are the same size, much like it works in the zip built-in. And finally, PDB's breakpoint and setTrace functions will now enter the debugger immediately instead of entering on the next line of code. It seems obvious when you think about it, but I'm sure at least one hardcore debugger out there just fell off their chair in excitement. And that's it! Wow, what a ride! There's so many more amazing changes that I haven't covered here, but considering the scale of this release, I'd be here until Christmas if I tried. Python has a lot to live up to, that's for sure. If there's anything here that caught your fancy, check out my Python 3.13 playlist to see if I've covered it in more detail, and let me know in the comments what your favourite feature of this release is. To be the first to know about any Python news, including any upcoming releases, make sure to subscribe so you don't miss a thing. Thank you for watching, and I'll see you next time for whatever we do next.
You know what happens when we are very close to 3.13 release, right? All the YouTubers in the planet go to the what's new and they use that to create their videos of like, what's new in Python 3.13?
Some already appeared. Some have more than 47 views.
Really? Wow. So yes, I mean, the what's new is quite important. Normally the release managers are the ones creating the document, but now that we have such a good documentation team, so shout out to all the people working on documentation. So this